Okay, selamat pagi semua. A very good morning to all. Happy Saturday morning. So I wish everyone in a good condition there and be ready for this lesson 3.4 electrical energy and power. Okay, it's a very short subtopic, but there are a few calculation need to be done in this topic. So as you can see, electricity is one of the chapter which involve a lot of calculations. So I hope you can spend your time to understand each of the calculation, how to solve a problem involving current, potential, different resistance, and so on. Okay, students. So what is the importance of learning this topic, electrical energy and power? One of the reason is to understand how our electrical bill are generate. You pernah tengok tak bil elektrik rumah kamu? Anybody used to have a look? Tak pernah. Kenapa? Sebab tu you tak keluar duit untuk bayar, so tak pernah ambil tahu. Okay, so actually before this they print out this bill for us, but now everything is online. So I don't think you have a chances to see it anymore unless you can check from online. You can check with your parents. Tengok berapa bulan mereka bayar untuk bil elektrik, berapa ratus. Okay, so how do we understand? This is example of electrical bill which is for this consumer. So you boleh tengoklah di sana jumlahnya. Okay, so how to understand this bill? Later we will talk in this chapter. So if you look here for this consumer, for this month, this is monthly bill. Okay, for this month, for example, this is the usage, the electrical power usage in kilowatt hour. They use about 274 kilowatt hour, mean 274 unit of electricity. And how do they do the calculation? So it is actually based on this tariff block. We call it as a tariff block. When you use the first 200, okay, if you use the first 200 unit, so this is the charge for each unit, 0.2180 ringgit. Okay, so you multiply with 200. And for the next 100 unit of usage or 100 kilowatt hour, this is the rate 0.3340 ringgit. So multiply with the unit. So you will get the total amount you have to pay for that much. Okay, so this is only one example of electrical bill from this consumer. So later you can check yours. Okay, check with your guardian macam mana bayar. And down here is another example from a different consumer. Okay, so again they show the tariff block. Okay, for the first 200 unit, they charge you this much for each unit. Next 100, they charge you this much. For the next 300, the charge will be increases. Okay, for the next usage, the charges will be increases if you notice. Okay, mean the more you use, the more you will pay. Itu logic lah. Okay, students. So in this content standard 3.4, electrical energy and power, there are 5 learning standard we must have a look at. So the first one is to formulate. Okay, how to formulate relationship between electrical energy, voltage, current, and time. You learned before this voltage and current. Okay, now we want to expand more this formula related to energy and time. And then second, how to formulate relationship between power, voltage, and current. Okay, in the second learning standard, before we learn voltage and current, now we want to relate it with power, electrical power. What does power means? Okay, and to solve problems involving electrical energy and power in daily life. Number 4, we are going to compare power and rate of energy consumption in various electrical appliances. So later in this part, we will understand how do they generate our electrical bill. And last but not least is to suggest way to save usage of electrical energy in household. Okay, so if this is our first learning standard. Before we go to our first learning standard, this is a few example of electrical appliances which you are normally seen at home. Okay, an electric kettle, a rice cooker, light bulb. What else? We have refrigerator, air conditioner, vacuum cleaner, and so on. Okay, including iron. Okay, so these electrical appliances convert what kind of energy? Electrical energy into other forms of energy. Can you name the other forms of energy, students? They convert electrical energy to what form of energy when you use them? Convert to electrical energy, convert to anyone? Convert to heat. What else other than heat? This light convert electrical energy to light energy. Fan convert electrical energy to kinetic energy and sound energy. For example, your washing machine convert electrical energy into kinetic energy, and you can hear sound from your washing machine, right? So sound energy also produced. This rice cooker convert electrical energy to heat energy and so on. Okay, ini contoh. Example, lamp produce light and heat energy when supplied with electrical energy. So the conversion of energy took place in lamp is electrical energy convert to light and heat energy. Okay, so what is electrical energy, student? Apa itu tenaga elektrik? So electrical energy is defined as the energy supplied by sources of electrical energy such as battery. This is what we learned before in 3.4 EMF when the current flows in a closed circuit. Okay. Okay, so let's get to our first learning standard to formulate relationship between electrical energy, voltage, current, and time. Okay. So these are all the things we learned before from the previous content standard 3.1 until 3.3. Okay, the first one. Remember, this is the definition for potential difference. What is potential difference? Energy supply or energy dissipated, energy transfer, okay, to 1 coulomb of charge that move across 2 points. And what is the equation for this? V. Okay, V potential difference of voltage equal to energy supply to move 1 coulomb of charge around across 2 points in a conductor. Okay, second, this is the definition for current. We learned in 3.1. What is meant by current, student? The red word, rate of flow of charge. So what is the formula for current? Rate of flow of charge. This Q is charge, I is current. So if you bring T to the other side, current is rate of flow of charge. Okay, so the first equation, V equal to E divide Q, we can write back in this form. Okay, we make E as the subject, energy as a subject. So Q we bring to the other side. So it becomes E equal VQ. Okay, and then these two equations we can combine. Okay, we can combine where Q here can be written in terms of IT. So what will be the product here? Can you tell me what equation we can derive here from the combination of these two questions? Okay, E equal VIT. Yes, very good. So this is the first equation, relate electrical energy, voltage, current, and time. E equal VIT. Okay, third, from Ohm's law. Okay, from Ohm's law, you learned before, potential difference is directly proportional to the current flow through the conductor, provided that the temperature and any other physical condition are kept constant. The length, the diameter, the temperature, and the resistivity of wire. Okay, from Ohm's law equation, V equal IR. So this equation, we write back here. The first equation we have derived E equal VIT. So this V now can be written in terms of IR according to Ohm's law. Okay, so you just substitute V into IR. So what will be our second equation here involving E, V, I, and T? So IR, then we have IT. So the equation is E equal I squared RT. Okay, from here. E, electrical energy, equal I squared current squared multiplied by resistance multiply time. Okay, can you see this? So far, are you following me? Boleh? Okay, then students, okay, this electrical energy, they are measured in a unit of joule. Okay, number 3, look at the third equation we can derive. Again, from the first one, E equal VIT. So now we can write this I, current. Okay, again, according to Ohm's law, I equal V divide R. Okay, so we can substitute I to V divide R. So what will be the third equation become, students?
V square T over R.
Okay, very good. So you will have E equal V squared T divide R. Okay, ini tiga-tiga ini you rasa dia bagi tak dalam formula list? What do you think? Given or not given? Not given, because this is the derived equation. Which one they will give you? They will give you the first one on top ini. V equal E divide Q. Okay, V equal IR, you have to check first, given or not given. Okay, but these three are not given. So now you know where they are derived from. Okay. Okay, that is the first one. So what does 1 joule mean? I say just now here, the unit, SI unit for electrical energy is measured in joule. So this means 1 joule of electrical energy refers to the energy that used when 1 ampere of current flows through an electrical device with a potential difference of 1 volt across state for 1 second. Okay, 1 ampere of current flows through an electrical device, potential difference 1 volt for 1 second. That is 1 joule of electrical energy means. Okay, so are you done with this slide? Can we move to the next one? Or do you have any question to ask?
No.
No. Okay, so far so good, I guess. So that is the first one, to formulate the relationship between E, V, I, and T. So these 4 parameters can be related into that 3 formula or 3 equation. Okay, now let us check our next learning standard. Again, to formulate relationship between power, voltage, and current. Now involve 3 parameters: power, voltage, and current. Okay, how to relate them, students? Okay, have you ever seen this label at the back part of your electrical devices? You nanti pergi tengok kamu punya peti ais, your refrigerator, your television, your iron. Okay, you can see this label behind them. We call this as a voltage level. So what does it show? This is one example of color TV. Okay, it labeled with this 240 volt. This is the frequency 50 hertz. This is the power 130 watt. Okay. So this TV operate at 240 volt, 700 watt. So what is meant by this label, students? So the first one, the label that shows here, display the voltage and electrical power required to operate the electrical appliances. Mean if you want this TV to function well, they must be supplied with a voltage of 240 volt and it operate at 700 watt, the power. Okay, then, so based on this label, we understand that, okay, this color, sorry, this one not 700 watt, supposed to be 130 watt. Okay, this one 130 watt. Okay, as shown here. So we understand here what does this label mean. It shows that this television will use 130 joule of electrical energy in 1 second. Okay, when operate at 240 volt. Okay, it will operate, it will use 130 joule of electrical energy in 1 second when a voltage of 240 volt is supplied to the television. Okay, so the voltage level, as I mentioned here, shows the working voltage of this color TV. What is working voltage? Apa itu working voltage? Potential difference required to operate under normal condition. Normal condition here mean they operate at the supply voltage. Okay. So what is the importance to understand this label? Because later we can use this information to calculate the amount of electrical energy that use over a period of time for this. For example, if you watch your television for 8 hours a day, later how much you have to pay for that TV in 1 month, okay, for that TV, for that radio, for the iron, for the refrigerator, for the washing machine, okay, how much you pay for each. Later we will look for that. Okay, then what is power refers to? Apa itu power, students? Power defined as rate of electrical energy transfer or rate of electrical energy dissipated or rate of electrical energy transformed into another energy when the electrical devices are in use. So this is the equation: power, energy divide time, rate, a rate of energy. So P is power, E is the time, E is the energy, T is the time. Okay. So back to our equation that we generate earlier. Do you remember just now we generate E equal VIT? Remember just now earlier from 3.4.1, E equal VIT. So we substitute this E into VIT. So then it will give you our first equation. So we cancel these two T. So we have P equal VI. Power can be determined from voltage multiply current. Okay. And the unit for power is watt. W-A-T-T. The symbol is capital W. Okay, welcome for those who just joined. We are now discussing our second learning standard, how to formulate equation relating power, voltage, and current. Okay, then next for resistor, lamp, heating element. When we combine this equation, P equal VI, where we generate here, and Ohm's law. Okay, Ohm's law. Resistor, lamp, heating element that obeys Ohm's law. So when we combine these two equations, what will be the come out, student? So from our first equation, P equal VI. Okay, so this V can be written in terms of IR from Ohm's law. Okay, so what will be the product here, student? What will be the product here? Yeah, very good. So P equal I squared R. Okay, so this is the second formula you can apply in calculating power. Okay, and then the third formula, ada satu formula lagi. Okay, again from P equal VI. Now we substitute this I, okay, using Ohm's law. So from Ohm's law, I is V divide R. So for this one, it will give us, yes, P equal V squared divide R, the third equation. So first one, P equal VI. Second, P equal I R squared. The third, P equal V squared divide. So when to use which one? When to use which? Nak guna formula 1 ke, formula 2 ke, formula 3? It depends on what information you are given in this in a question. So you have 3 options to determine power. Okay, either the first one suitable, second, or the third one. So you have to check on the situation given in each question. Okay, that's it for second learning standard. So the first and second learning standard is to formulate an equation relating E, P, I, T, R, and V. Okay. So now let us take a look at the third learning standard. Okay, it's to solve problem. Just now we generate the formula. So this is now where to use them. Okay, so you can get ready with your calculator. Okay, before that, let us check this example in your textbook. Boleh buka buku teks, boleh tengok contoh ini dulu. Okay, the first one. Okay, they give you a circuit here connected to 6 volt power supply, and there's a bulb. It shows that circuit supply with 6 volt battery to light up a lamp. Okay, if the current is 0.7 ampere, what is the amount of electrical energy used to light up the lamp for 1 minute? So there is a few information you are given there. Okay, this is the voltage, then the current, this is the time of operation, 1 minute. Okay, so this is the proper solution for you in order to solve any problem related to calculation, as I mentioned earlier. So you can identify the problem and extract all the information given, then determine which formula are applicable, finally do the substitution and write your answer in correct 2 decimal places and correct unit. Okay. So what is our problem here? We are looking for total energy use, amount of electrical energy use. Okay. So what is the information given? This is all the information you are given. The potential difference is 6 volt. Okay. Current flows through the bulb 0.7 ampere, and this is the time operation 60 second. Okay, 1 minute. So it is 60 second. Okay, now which equation you think we can apply here to find electrical energy? So we are looking for E. We have V, I, and T. So this is the first equation, right? We generate from 3.4.1. So you boleh guna juga this one. So E equal VIT. We are using this E equal VIT. Alright. So can you tell me what is the answer for this? Find the electrical energy used to light up the lamp for 1 minute. Okay, please count, student. V is 6, I 0.7. The time is 60 seconds.
The answer is 252.
The answer is yes, very good. 252 joule energy. 252 joule. Easy, right? Okay, then second example. So this is the formula we apply. E equal VIT. Okay, second example also from your textbook. Example number 2. A fluorescent lamp labeled with this power rating or voltage working label. First, find the lamp resistance, the resistance of the lamp. The current flowing through the lamp under normal condition. Normal condition mean when it supply with 240 volt. Third, electrical energy supply for 3 hours in kilojoule. Okay, 3 hours, they want you to put in kilojoule unit. Okay, how to find the resistance of the lamp? Okay, students. So you write back all the given information. 32 watt, this is the power. Okay, potential given across the lamp, 240 volt, equal to the supply voltage. Okay, so they ask you for resistance. So we can use this equation from the third equation, right? Where P equal V squared divide R. This is the formula. So we are looking for resistance. So we put resistance as a subject. So we bring the power, they swap places, power and resistance. So it becomes this. Then you just do the substitution. Okay, 240 squared divide with the power 32. So it gives you 1,800 ohm. Okay, then find the electrical, find the current flow. Find the current flow. So this is the information you are given. Okay, this is the potential difference. So they are related through this equation. P equal VI. Okay, so we can find this I by bring V at the other side. So P divide V. Okay, as shown here. So P 32, the voltage 240, so the current is 0.13 ampere. Okay. And then C, find the electrical energy supply for 3 hours in kilojoule. So you must alert with the unit they want you to write, kilojoule. Okay, so again, the power 32 watt. This is the time of operation, 3 hours. So in second is 10,800 second. Okay, so this is how we write electrical energy when giving power and time. Okay, the general formula. So you just substitute power 32, the time. So this is the answer in joule. But remember, they ask you to write in kilojoule. So we are not finished yet. So how to write in kilojoule? Divide by 1,000, right? Divide by 1,000. So you move 3 point forward. 1, 2, 3. So they will give you 345.6 kilojoule. You put the K there, symbol for kilo. Okay, how do you find example 1, example 2? Easy, right? Nothing difficult yet. So you just play with the formula we generate from 3.4.1 and 3.4.2. Okay. Okay, ini tadi your option lah, power. The equation that we apply. So for A, we apply this. And then for question B, we apply this formula. And for question C, this is the formula we are applying. Okay. Okay, now let's come to the example of question in your module. Okay, our first activity to solve problem involving electrical energy and power in daily life. Okay, the first two question, can you give a try? Alamak, ini sudah terkeluar pula jawapan. Okay, do the first one. Number one, we have a bulb label with this power rating 240 volt, 60 watt. Okay, the question is find the energy used by the bulb in 1 minute if it is connected to 240 volt supply. So we understand here when it is connected to 240 volt supply, similar to the potential difference required. So we know that this bulb is now working under normal condition. Okay, so find the energy use, student. Once you get, you can share your answer in the in-call messages. Boleh share jawapan. Cuba kira ya number one ini. So from this label, they give you two information, the voltage and the power.
Teacher,
Yes.
my answer is 864 kilojoule.
Which one? For number one.
Yes.
Okay, later we check. Okay, can you write it in the in-call messages? Can you type? Boleh type ke? You masuk guna, you follow this lesson using your handphone or using computer, laptop? Handphone.
I'm using Vision account.
Okay, no problem. Okay. As long as you are here, thank you very much for your commitment, everyone. So far, we have 25 students here out of 105. Yang lain tu pergi mana? Belum bangun ke? Okay, Wei Shen got 864 kilojoule. Nicholas got 3,600. What about the rest of you? What do you get? Cheryl dapat berapa? Eliana, Eric, Zejun, Chen Hui, Li Chun Yao, Chun Chuan, Wei Xin. We have Jia Yi, Yi En, Qing Xiang, Yi Xian Sun Xiang, Zixuan, Ke Yi, Jun Wei, Yu Hui, Wan Jia, Shamel, Yuan Han, Hong Zhe. Siapa bawah ni? Wei Xiang, is it you? Okay, students, are you done with number one? Okay, let us check. Okay, so let us check how to find the electrical energy use. Okay. Okay, so this is all the given information. So you list out first the given information. They give you V, 240 volt. They give you the power, 60 watt. Okay, the time 1 minute. Okay, so you can change this into 60 seconds, convert into seconds. So we are looking for E. So we have V, P, T. How to find E, student? Macam mana nak kira E? What formula you are using, Wei Shen? BTTM is apa? What is BTTM? Bottom.
E equals to VIT.
Okay, so you boleh guna. Actually, you boleh guna ini juga. You can use this. Simple. E equal to PT. You can use the power and the time of operation. So answer is 3,600. Okay. Dapat 3,600. Okay. Second. Okay, we have this diagram. Shows electrical circuit. What is the power dissipated in the resistor when the switch is on? Okay, where is our resistor? This is the resistor. So how much power or how much energy is used in 1 second? That is meant in this question. Okay, how much power when the switch is on? Okay. So ini you tengoklah apa formula yang what is the information you are given with. Okay, so we are supplied with all this info. V, 6 voltage, 6 volt. The voltage is 6 volt. Resistance across the resistor is 5 ohm. So we are looking for power. So how to relate these three, students? V, R, and P, how to relate them? So the equation is P equal V squared. divide R. Okay, P equal V squared divide R. The third formula for power. So V squared is 6 squared divide by R which is 5, so give you 7.2 watt. Okay, susah tak soalan 1, soalan 2? This is
So
the basic.
susah.
Susah. Apa yang susah? So you can list out all the related formula, then you choose mana yang boleh guna. Actually, in some question you can apply more than one formula. You guna formula yang berbeza, tapi you end up with the same answer. Okay, so you have option. Alright. Okay. We try the next question. Okay, never mind if you didn't get. For example, this one I listed all the three related equation for power. The first one, P equal VI. So this one cannot use because we are not supplied with the current, right? So this one is not available for question 2. For this question. Okay, equation number 2 also got I there. So ini pun tak boleh pakai because we are not supplied with I. Unless you nak kira I dulu, boleh juga sebenarnya sebab you ada this one. So you can find I. But it will require more step lah. Okay, so we use this third equation. We have V, you are supplied with R. So that's why we are applying the third equation. Okay. Okay, next student. It means that in question 2, kalau you nak cari I dulu pun no problem. You can find I is V divide R. 6 divide by 5. So 6 divide by 5 berapa? 1.25. Is it? Betul ke? 1.2. 6 divide by 5. 1.2, right? Give you the current 1.2 ampere. So you nak guna ini boleh lah. Now you can use equation 1. P equal VI. V is 6. Current 1.2. So you end up with the same answer. 7.2 watt. Ataupun sekarang you nak guna yang second, can because you find the current. P equal 1.2 squared multiply resistance 5. So you akan dapat juga sama ke? You akan dapat 7.2 watt. Means here you can apply all equation. The first two you can apply if you find the current first. But if you don't want to find the current, you use straight away what I've given here. So you simply apply equation number 3. So these are the options you have in a certain question. Okay, now let's check. Let's try question number 3. Okay, question 3, student. Okay, this is a diagram. You can see a filament bulb connected to a dry cell. Voltmeter reading is 3 volt and the resistance of the filament is 3 ohm. So they give you two information here. V 3 volt and R 3 ohm. So find the ammeter reading in the circuit. So in A, what are we looking for, student? What are the parameter they ask you to calculate? Ammeter reading means find the current. Yes, very good. Find the current. So what is the current? Flow across the bulb. Second, charges flow through the bulb in 2 minutes. Charges flow. Charges flow. Charge is Q. Charges flow. Q. Then find total electrical energy. So convert into heat and light in 2 minutes. So here they give you the time, 2 minutes to find E, electrical energy. Okay, do A first. Berapa? Nicholas have stated the related formula. Okay, please work on number 3. Everyone, test your understanding. And then you can share your answer here. All right. Okay, Wei-Shen say 1 ampere, the reading of the circuit, reading of the ammeter, 1 ampere. Do you agree? Eliana also say 1 ampere. Okay. So I think the first one, no problem. You are given with R, you are given with V, so you can find I. Equation, the charge 120 coulomb. Okay, energy 360 joule for C. Okay, the rest of you, what do you get? Is it raining in your place now? Is it raining there in Butterworth?
Heavy rain.
Yeah, it's just rain in Kepala Batas here. Okay, students, Ang Jin Pei, good morning. Okay, now we are doing question 3 in activity 1 in 3.4, electrical energy and power. Okay, student, let us check for the answer together. Okay, so I erase first this ink. Okay, the first one, yes, very good. So we are using this equation. AI equal V divide R. Okay, this is from Ohm's law. Okay, I equal V divide R. So give you 1 ampere. Very good. Okay, then charges flow through the bulb in 2 minutes. Okay, so this is equation for charge. Q equal IT. So the current we have calculated in A. So we have the time 2 minutes. So 2 minutes convert into seconds. So very good. They give you 120 coulomb. Okay, see, electrical energy convert to heat. Okay, so you can use this equation. E equal I squared RT. So this is the substitution for I. This is R and this is the time. Okay, did you use this equation or you use another one? Another equation.
Yes,
What
we use this.
equation you are using?
Yes, yes.
You use the same with mine? Okay, so the answer is 360 joule. Okay, are you clear everyone how to do number 3? Yan Han, are you doing good there? Hongzhe, Aiman, Syamil boleh buat. Wanjia, Yu Hui. Okay, Junwei, did you get all correct answer for number 3, A, B, and C? Ke Yi? Okay, very good. Okay, thank you everyone. Okay, let's move to our next question. Here we go a bit fast. Number 4. Okay, now we have a fluorescent lamp, okay, with this label. So what do you understand from this label, everyone? Can you explain what this label mean? 240 volt, 40 watt. What does it mean? What does it mean? Sometimes it come out in the question. Dia suka tanya soalan macam ini juga. Okay, what is meant by 240 volt, 40 watt? You pernah jumpa kan kalau you banyak buat soalan? You must come up with this question. What does it mean? 240 volt, 40 watt.
Okay,
yes,
the
Jinwei.
sentence, huh?
Yeah, the sentence. What does it mean by this label? 240 volt, 40 watt label on the
40
fluorescent
joule
lamp.
of electrical charge uses the operation of 240 volt. I think so.
Okay. You missed one thing there. 240 joule, 40 joule of electrical energy. 40 joule of electrical energy used in 1 second when operate at 240 volt. As written by Nicholas there. You must mention 40 joule of energy used in 1 second. Mention the time, 1 second. Because that is the power means rate of energy. How much energy used in 1 second. Okay, are you clear? So you can say the fluorescent lamp use 400 joule energy in 1 second when operated at 240 volt or when supply with 240 volt. Okay, boleh ya yang lain? So if they ask you in the question, what is meant by this label? 240 volt, 100 watt. So you can write the electrical appliances use 100 joule energy in 1 second when operated at 240 volt. Simple. Boleh ya? Okay, now find the resistance, students. Iting, welcome. Okay, find the resistance. Again, we are given with V and P. So to find R. So how can we relate V, P, and R? So you check from the 3 equation we derived just now. So you can use the third equation, right? R equal V divide P. Sini V squared divide P. Okay, it is generally from this P equal V squared divide R. So this one we swap the position, bring R to this side, so we bring P down here. Okay. So V squared 240 square, you tak mau buat macam ini pun tak apa, you just write this way, 240 squared. Okay, divide with the power is 40. Okay, then is this answer correct? 40 joule of electrical energy is used in 1 second and operation. Yes, can Wei Shen. Okay. You mentioned about the energy, 40 joule, mentioned about the time, 1 second, and mentioned about the operation voltage, 240 volt. Okay, so is it correct? 1440 ohm, students? Betul ke?
Yes, yes.
Okay, how about B? Find the current flow through the lamp under normal condition. So when it right here, normal condition mean it operated at the supply voltage at 240 volt. Okay, so what equation to find current in B? So now you have 3 info. You have V, you have P, from A you have R. How to find I? Boleh guna salah satu saya Sinway. So boleh guna inilah I equal P divide V. From this equation, P equal VI. Okay, so to find the current, we bring V to this side, so it becomes division. Okay, power 40, this is the voltage, 0.167 ampere. Okay, actually this one you have another option. Boleh guna persamaan yang lain juga if you prefer. Okay, but you will end up with the same answer if you calculate it rightly. Okay, the third one, C. Electrical energy supply for 3 hours. This one 3 hours. Okay, you must be careful with the time given. Sometimes they give you in second, in other question they give you in minute. As for this, they give you in hours. And they want you to write the answer in kilojoule, the unit. Okay, so find E, students. E, electrical energy. Okay, supply for 3 hours in kilojoule. So now we have 4 parameter there. V, P, we have R. From question B, we have I. So you can choose which equation is applicable for C. Anybody done? What is the electrical energy supply to the fluorescent lamp in 3 hours? Okay, Zishuan, are you done for C? Yu Hui? Wanjia? Sun Xiang, are you doing good there? Eric, okay, on the way, okay. Cheryl. Where is your friend, Cheryl? Sri, I didn't see Sri here. Okay, Ian, Jia Yi, are you doing good there? Hui Xin, this is the Three Stooges. Hui Xin, Jia Yi, Ian.
432,864 Joe.
4, 3,
432,864.
we have 3 different answer here. Eliana with 432,000 and Junwei with 4333, 729.728. Okay. And 432,864. Okay, we check for the correct answer. Okay, so how to do C? Okay, so this is the equation I'm applying here. Energy is power multiplied time. Okay, so the power is 40 watt. Okay, so we are using 3 hours, right? So 3 hours convert into minute first, multiply 60, and then multiply into second. So you multiply another 60. Okay, so is this value correct? 432,000. Siapa dapat 432,000? I count again, 40 times 3 times 60 times 60. Yes, it is 432,000. Okay, so you check back. Junwei, where did you get it wrong? Eliana, very good. Yeah, Junwei silap di mana? You tengok cikgu punya answer. Is it on the time? 4333728. Okay, so you tengok ini equation dia. Power is 40, this is the time, 3 hours. So in kilojoule again, so in kilojoule, so we move 3 point forward. So it give you 432 kilojoule. Okay, don't know where is he. Okay, so student can, okay, this is the correct answer for C. I use formula E equal I squared RT. Okay, kita tengok E equal I squared RT. Ada formula ini tadi, E equal to I squared RT. Okay, tengok. So I berapa tadi? 0.167. 0.167 squared multiply R. What is R? R is 1440. Then multiply the T this one lah. So this T you must write correctly lah. 3 times 60 times 60. Okay. So tengok. Mungkin you akan dapat beberapa jawapan yang berbeza. Nanti cikgu tengok. 0.167 squared multiply 1440 multiply 3 times 60 times 60. So answer 33372. Jawapannya beza sedikit. 33372 because this one on the number on decimal places you are using here. Kalau you guna 0.17, then the answer will be slightly different. You are using 0.167, then answer will be slightly different. So apa lagi formula you guna? E equal to VIT. E equal VIT. Okay, you can check. You replace lah with the value. V is 240 multiply current. Current is 0.167 and you multiply with the time. Okay, I calculated first. 240 times 0.167 multiply 3 times 60 times 60. Okay, so 432,864. Okay, for this formula, you will get 432,864. Okay, so there is slight difference when you are using different equation. Okay, so for this kind of question, so you don't have to worry. Tapi cikgu nak advise you jangan tunjuk setiap step. Okay, sebab you pilih satu saja. You just stick to one formula. Because what do we find here? Each formula give you slight different answer. So but during the exam, you don't do all formula sebab you rasa tak selamat kalau you buat satu saja. You don't have to worry because for this kind of question in a marking scheme, we will put there an option. Okay, when student A use formula 1, so this is the answer he's supposed to get. Student B use formula 2, this is the answer he's supposed to get. Student C use formula 3, this is the answer he's supposed to get. Okay, so are you clear with that, student? Boleh? As long as the formula is correct, because we have different formula. Tadi ada 3 formula for E, right? Okay, so you just use one in your calculation. Don't show all 3. Okay, you just show one. Okay, as long as the your substitution is correct, your formula is correct, and your answer is correct according to what you calculate. Kalau you kira dengan betul, you won't have to worry. You akan dapat markah. Boleh ya? Okay, are you clear with that? Alright. Okay, so that is a few example of question involving the 2 formula we generate earlier from 3.4.1 and 3.4.2 to find power, electrical energy use, resistance, current, voltage, and so on. Okay, can we continue with learning standard 4, student? Compare power and rate of energy consumption in various electrical appliances. Okay. This is the first example in the 4th learning standard. Okay, before that, any question you want to ask? Are you doing good so far with the first 3 learning standard?
Yes.
Okay, very good. How about the rest? Are you all doing good there? Okay, still on track? Okay, very good, Junwei. Thank you for your response. Okay, this is the information you are given about 2 torchlight bulb, L and M. Okay, we have bulb L and bulb N. Potential different for each, 2.5 for L, 6.2 for M. And the current flow across the bulb, 0.3 ampere for L and 0.5 ampere for M. Okay. They ask you to compare the brightness. Compare the brightness of the two bulbs when they are used under normal condition. How to make a comparison here, student? Compare the brightness of the two bulbs when they are used under normal condition. Okay, how to compare the brightness? Any idea how to respond to this question? Which one do you think will light up brighter, L or M? According to the information given here, they give you the potential difference and the normal current of current flow, 0.3, 0.54 M. Wei Shen say M. The rest of you, what do you say? Teka saja, salah tak apa. Which one do you think? So find R equal to, so Junwei find the resistance. So he say M, R equal to V divided I. So the rest of you, what do you say? Okay, so let us check. Okay, so how to find this? Yes, bulb M is brighter. Why? Why bulb M is brighter, student? So kalau you tengok sana Junwei, dia measure resistance sana. So R equal to VI. Can you find the resistance for each bulb? What is the resistance for L? 2.5 divide 0.3. How about M? Resistance for bulb M. Potential difference. So 6.2 divide 0.5. Okay, berapa jawapan dia this one? 2.5 divide 0.3 give you 8.33. 8.33 ohm. Okay, this one 6.2 divide 0.5. Berapa ni? 6.2 6.2 divide 0.5. Dapat berapa ni? 12.4. 12.4 ohm. Okay. So you tengok di sini, dia punya resistance brighter 12.4. So student for light bulb, you tengok when the resistance is higher, so it will generate more heat in the bulb. So the bulb will be light up brighter. So that's why the answer is bulb M. Okay. Number 2, how many joules of electrical energy in 1 kilowatt hour? You have to respond to this. How many joules of electrical energy in 1 kilowatt hour?
Teacher, may I have a try?
Yeah. Sorry.
In the words,
Okay.
form,
Okay.
1000 joules of electrical energy is used in 1 second under 240 watt.
Come again.
1000 joule of electrical energy is used in 1 second.
Is it? Okay, how about the rest? What do you say?
Uh,
Okay, tak apa, it's a good try. Nanti kita tengok. So how to find it? How many joule of electrical energy in what kilowatt hour? Okay, students, our electrical consumption at home is given or is calculating under this unit. Kilowatt hour. Mean how many kilowatt you are using in 1 hour. So kalau sini you tengok according to this equation, E equal to PT. So the power is 1000. 1000, 1 kilo. So 1 kilowatt is 1000 watt. Okay, so this our, so how many? So 3,600,000 joule of electrical energy. Boleh nampak question? Who is this with the Chinese writing name? Is that you, Kafai? Oh, siapa ni? 3,000 yang tulis 300.
Kafai.
Kafai.
Yes.
Oh, that is Kafai. Okay, sorry because I can't read Chinese. Okay, so we understand this is the amount of electrical energy in joule provided in this 1 kilowatt hour. Okay, students. Okay, now number 3. We have kettle now, electric kettle connected across, wrong spelling there, 240 volt power supply. So this is P. Okay, resistance 40 ohm. This is R. Find current flowing. So this is similar with learning standard 3. And here quantity of heat produced in 10 minutes. Quantity of heat produced in. So quantity of heat here refers to what? Quantity of heat produced in 10 minutes. It refers to the apa tu quantity of heat? Heat itu a kind of what? Heat is a kind of energy. So we are looking for energy in question. Okay, find the current flow. You have P, you have R. So you can find R. Okay. Answer 6A, Junwei say for A. Okay, how about B? Quantity of heat produced in 10 minutes. So 10 minutes. Okay, so you have to convert this into second. 864,000 joules said by Kafai. Okay, we check first for A. Yes, very good. So from these equations, okay, power supply. Okay, sorry, ini bukan power lah. 40 volt, sorry. This is supposed to be the voltage. Okay, 40 volt power supply. Okay, so the voltage 240, resistance 40. So yes, 6 ohm. Very good. 6 ampere. Okay, fine. Energy, heat energy. Okay, very good, Kafai. So we can use, are you using this equation? E equal VIT? Or which equation you are applying? So voltage 240. This is apa ni? 240 current I 6 ampere, and this is the time. 10 minute convert into seconds, so multiply 60. Okay, this is V, this is the current, this is the time of operation. So 864,000 joules. So if they ask you to write in kJ, so answer is 864 kilojoule. Okay, that's it for number 3. Okay, number 4, student. Very fast. Number 4 now.
I have
Yes.
a question to ask.
Which one?
The number one, why the M is brighter?
Kenapa? Why M brighter? Tadi? Because this is light bulb.
Tapi kami kira resistant and their resistance larger than.
Sebab light bulb ini dia operate based on heat produce. Mean the higher the resistance, more heat produced in the light bulb. Sebab dia heating element, the filament itu heating element. Okay, so the higher the resistance, mean the higher the heat flow to, so the brighter the bulb will be.
Kalau normal punya bulb macam kami guna punya normal bulb.
Bulb itu, that is the way it operate, because the filament across the bulb itu is act like a heating element. Like a heating element in iron, heating element in rice cooker. So the more the resistance, mean more heat it supply.
So means that in all bulb, the higher the resistance, the bulb is brighter.
The bulb is brighter lah for this one. Okay.
Just for this one or for all
Bulb
bulb?
lah, for normally for bulb, because they work based on heat generated in the filament across the bulb. Okay.
Okay. Thank you.
Okay. Cynthia, what question do you ask there? Is it more lighter, more temperature, then more resistant? What is it? More lighter, more temperature, more. When you generate more heat, of course the bulb will be hotter. So hotter mean the temperature will be higher. Okay.
Teacher.
Yes.
Is it the power determine the brightness of the bulb?
Power determine. Power itu determine. Power itu tadi masuk apa?
P equal to VI.
Rate of heat. Power itu rate of heat generate. Rate of heat generate. All the heat, it does the heat that generate, sometimes it lost in a few forms, or means not 100% of the energy used is convert into light. So you cannot say the more energy, the higher the power, the brighter the bulb is it. Tak semestinya. Okay.
Okay.
It depends on the efficiency. Nanti kita belajar efficiency, because in more some of our electrical appliances they have high efficiency, some has lower efficiency. Higher efficiency mean they use most of the power generated in operation. Less efficiency mean some of the energy is waste in another form, for sound, form of heat, and so on, due to friction across the bulb. Okay. Okay,
Okay.
then student number 4. Immersion heater. Kita ada immersion heater, power rating 240 volt, 700 feet. So you understand from here, this immersion heater dissipated or generated 700 or use 750 joule of energy in 1 second when operate at 240 volts. So what is the resistance? Find resistance. Again, find resistance from V and P. Okay. Yeah, so Junwei get 76.8. Very good, Junwei. Okay, so this is how we find the resistance. How much electrical energy is missing there, is used in 15 minutes. Okay, how much E is used or is generated in 15 minutes? So you can find from this equation. Did you get the same answer with mine? Power 750. The time 50 minutes convert into seconds. So this is the power. This is the time. So 675,000 joule. Okay. Okay, done with number 4, students. Okay, we have more question here. Number 5, number 6, and number 7. Ada yang sudah tired ke kira-kira? Are you still doing good there? Okay, boleh lagi. Okay, very good.
Sorry, teacher. Could you please back to the previous slide?
Which one? Number 4.
Yeah,
Question
the number
This one.
3 one. Oh,
Okay.
number 4.
Number 4. It says the answer for the resistance 76.8 ohm, and this is your power for the electrical heat used in 15 minutes 675,000 joule. All right. Okay, number 5. Okay, this is the diagram. Show 3 bulb. We have bulb A there. Where is bulb A? This is bulb A, bulb B, and C connected to a power supply of 12 volt. Find the ammeter reading. This is related to the previous topic. Find ammeter reading, students. The ammeter is placed here at the main circuit. So how to find the ammeter reading? Number 6, you are given two resistor P and Q, both 1 ohm and 2 ohm respectively. Find the power dissipated by each resistor. Find the power in each resistor. What is the power in P and what is the power in Q? And question 7, this is the diagram. Show two resistor connected in parallel. P is 1 ohm, Q is 2 ohm to a 12 volt battery. What is the power dissipated by each resistor? Similar to question 6. Okay, question 7 is similar to question 6. Only the arrangement is different. This one P and Q arranged in series. For this one P and Q arranged in parallel. Okay. How to do number 5? Find the ammeter reading. Okay, any idea how to find the ammeter reading? So for this junction, you can see what is the supply voltage there. Supply voltage is there is 12 volt. Okay, and the power rating, the effective power rating there is 24 watt. Okay, at this junction. So we understand A and junction B all are operated at 12 volt, 24 watt. Okay, same with the operating voltage of the power supply. Okay, so how to find current? So how to find current? So current P equal I equal to P divide V. Okay, so this is our power. We need the equation I equal to power divide voltage. Okay, the power is 24 and the voltage is 12. So give you 2A. Dapat ke 2A? Siapa dapat 2A for question 5? A to A for question 5. Okay, question 6. What is the power dissipated for each resistor, student? Let us give a look. Okay, so ini. I1 yang ini, I1. Ini belum habis lagi, sorry. Okay, this one. I1 ini current flow in this one, A1. I2 the current flow in this junction, okay, for this one. Okay, then the main current is 4 ampere. Nanti cikgu padam semula. Right. Okay, so this one, if you understand this circuit current flow here, so it will be divided into two junction, right? Two branches. Part of the current flows through here. So part of the current flows through bulb B and bulb C. Okay, so ini berapa current flow across this? Show by this one. Okay, current is the power by this bulb 24 divided by the voltage across the bulb. So 2 ampere flows to here. So you need 2 ampere. Okay, and then second, okay, the total voltage here is 12 volt. Okay, since they are in series, so the total voltage macam cikgu kira tadi, so 12 volt. Okay, and the total power is 24 watt. So you masuk yang inilah, the power is the power is same. Macam mana dapat ni? 12 divided by 6 sebab dia sama. So means current flow at B 2 ampere. This one also 2 ampere flows here. Boleh faham tak ini? So the total current when they meet back at the end of this junction 4 ampere. Then so the current flow in the main circuit is 4 ampere. Is all bulb work based on the principle of energy level. Can you explain energy level? Kafai, principle of energy level. Can you share with others what is energy level? Bohr punya model. Bohr punya model ni model yang mana? Yang lain you kenal ke siapa itu? Charles Neil Bohr. Is it Charles Neil Bohr you refers to? You refer to his model? Okay. Is the bulb work based on principle of energy level? Okay, so bulb ini kita punya conductor. It work based on as what any conductor operated at lah according to what we learned before. So ini kita for your level kita tak refer lah kepada energy level. Okay, that one you can explain more detail if you go to higher level. Above SPM level, but ini kita lebih simple saja, so we based on Ohm's law only. Okay,
Teacher, if today itu bawah bab dua bab itu ada satu tak sama.
Apa yang tak sama? Okay, sekarang you tengok yang ini I2. Okay, I2 this one. Okay, ini kenapa pakai 12? Ini dia punya power. Okay, this one B kan. You tanya apa yang tak sama?
Kalau bab D dan bab C, ada satu yang tak sama voltage dan power.
Tak sama voltage dan power. Macam mana? Tak sama voltage dan power.
Kalau macam B dia punya power 7 and the voltage is 10 lah.
Then how?
I also use the same method to calculate lah. VIR.
Same method, but normally for ours, sebab yang kita belajar sebelum ini current flow in series connection sini, okay, dia punya current semua sama kan, in series, correct? In series. So that's why di sini they give you same power rating supaya dia punya current yang flow itu sama, means dia operate at normal condition. Boleh
If in series the current flow always same.
Because if you look at the power supply sini 12 volt, okay, so mean dia punya voltage di sini mesti sama dengan voltage power supply 12 volt. So bila you tengok sini 6, this one also 6. So bila you total, you dapat 12 volt with the power supply voltage. So bulb ini kalau you nak dia function normally, so dia punya the first one, dia punya voltage supply itu mesti sama. So since sini we are using 2, so that's why ini dia punya 6 volt. This is also 6 volt. Okay, boleh? Kalau you pakai di sini 12 volt, 12 volt, 24 watt. Sini pun 12 volt, 24 watt. So macam mana sini dia punya total voltage nanti 24. Greater than the power supply. So apa maksud dia? Can someone explain this? Kafan, can you help explain this? If I put here bulb with 12 volt, 24 watt. This one also I put 12 volt, 24 watt. So what will happen to these two bulb?
More brighter.
Anyone can explain this?
Teacher, but the sources supply voltage is only 12, but
Dia
your
tak
sum is
cukup.
24.
So you will get insufficient. Sebab ini you supply 12 saja. Now ini dia provided, dia mesti 24. So in this condition now dia tak boleh operate at normal condition. So apa jadi pada dia nanti?
So the bulb will not light,
Dia
will not
tak
light on.
hidup. Okay, sebab dia punya power tak cukup to operate them. You supply tak cukup power, tak cukup voltage to operate them. So that's why when you place a voltage there, it must meet what supply from the electrical sources of energy. Boleh faham Okay.
Teacher, it seems like the sources voltage is lower than the junction voltage, so it cannot function.
Cannot function. Okay.
Okay.
Okay, kita tengok answer for these two. Question 6. Okay, for question 6. Find the power dissipated by each resistor. So to find power dissipated, okay. So you must find first what is the current flow. Kena cari dulu apa current flow in this circuit. So how to find current flow? You are given with supply voltage 12. So from here you can find the effective resistance, right? They are in series. So dia punya effective resistance is 1 plus 2, 3 ohm. Sini. So you can find the current flow from this one, P divide V. V divide R, V divide R. So 4 ohm. Okay, then you can find the power by using this formula. P equal I squared R. The current flows across, multiply with the resistance for each. So for bulb P, it is 14 watt, and for bulb Q, it is 32 watt. Ini 14, ini 16 watt, this one 32 watt. Okay, tapi dia punya voltage mesti total tu ini mesti 12 volt. Sama. Okay, boleh ya? Okay, now 7. Same question but only the arrangement is different, parallel. So now PQ are arranged in parallel. Again, you have to find the current flow. So for this one dia guna macam mana? So for P, okay, this one find the power dissipated by each resistor. Okay, so this one for P, dia guna formula ini. B squared divide R. Okay. This one dapat 144 watt. Okay, this one 72 watt. So are you clear question 6 and question 7, students? Question 6 and question 7. Ini kalau you nak find I pun no problem. As you do in number 6, you want to find I first, you find the effective resistance for this junction. Then you can find. Tapi ini dia terus guna this formula P equal to V squared divide R. Kenapa terus guna ini? Because we understand here all this junction ini semua 12 volt. This one also operated at 12 volt. Similar to the voltage supply by the battery which is 12 volt. Okay? Boleh? Alright. For this one, kenapa dia cari I? Sebab V dia tak bagi di sini. Ini dia tak bagi V berapa. This one also we don't know the V. We only know the total. Total for VP and VQ total is 12. But we have two unknown. We don't have V, we don't have I. So that's why here they ask I first. Then only you can find the power. Untuk ini, you know the V for each which is equal. Ini semua all parallel, so 12 volt, 12 volt. So that's why it straight away can apply this equation. Okay, that is the difference with question 6 and question 7. Okay, do we still have time? 7 minutes before 5 arcade go to their chemistry lesson. Okay, ada apa nak tanya tak? I think this is our last question for today. Mungkin kita cuba. Okay, we have this General electrical appliances at home, fan, television, computer, air conditioning and washing machine. Okay, this is the power rating for each student. So I hope now you are clear what is meant by this power rating, and this is the time operation, okay, for each. So we want to find the energy consumption for each in a unit of kilowatt hour. Okay, tolong kira berapa for this one? For fan, the power consumption in kilowatt hour. So you nak darab sajalah ini power time, darab dengan time of operation in hour. So ini in kilowatt, so this is what, so semua ini kita kena divide by 1000. Okay, so that's why you have this. Multiply 1 hour, so 0.05 kilowatt hour. Okay, for television, so in kilowatt, this one also divided by 1000. And then you multiply with 1, ini pun divide by 1000, this one divide by 1000. Ini pun divide by 1000. Kenapa divide by 1000? Because this one they give in watt. But we want in kilowatt. So this is the consumption for each. Television 0.1 multiplied by 1 hour, so 0.1 kilowatt hour. For computer 0.2 times 1, 0.2 kilowatt hour. 1 kilowatt hour for air conditioning, air conditioner, and 0.9 kilowatt hour for washing machine. So nanti you boleh total ini. When you total the value in kilowatt hour, then you can know how much you have to pay for 30 days, for example. How much energy? Yes.
The kilowatt hour is joule or not?
Bukan joule, dia kilowatt hour, kilowatt.
Okay.
Watt itu joule per second. Watt itu joule per second. So sekarang kita tak mau pakai joule per second, kita pakai watt saja. Kilo mean 1000 lah, ini divide by 1000. Okay? Boleh. Kalau kita nak kira energy consumption, ini you kena hati-hati. Dia punya time ini in hour. So time dia you don't have to convert into second. For energy consumption, dia punya unit kilowatt hour. So the time must be in hour. Sebab ini semua cikgu guna hour, tak tukar pergi second. Tapi kalau you nak guna energy used, E equal to VIT, itu must be in second. Ini kita guna bila kita nak kira kita punya electrical bill, electrical consumption in a certain period of time. Boleh faham beza dia? Okay, ini contoh lah. Kita tengok satu contoh kira. Students, okay, kita nak habis dah. Appliances with power 2 kilowatt used for 10 minutes, 3 times a day. Okay, 3 times a day. If the cost for electricity is 25 cents per unit, what is the cost of operating the appliance in a month of April? Soalan ni sekarang kita nak kira electric bill. Okay, so this is the information you are given. Ini dia punya power 2 kilowatt used for 10 minutes each time, and you are using it 3 times a day. Ini dia bagi cost of electricity is 25 cent per unit. Okay, satu unit, 1 unit equal to 1 kilowatt hour. Ini unit for energy consumption. Okay, 1 unit equal to 1 kilowatt hour. So berapa banyak you kena bayar in a month of April? What is the cost of operating these appliances in the month of April? Particular 750. So month of April you kena tahulah ada berapa hari month of April. 30 days. Sometimes they give you the specific month. So if they give you July, for example, July it must be 31 days. But kalau dia tulis month saja, in 1 month. So in 1 month kita nak ambil yang mana normally student? If the question mention in 1 month only, not specific month. So kalau 1 month kita ambil 30 days, 30 days. Okay. So how to do this? Macam mana? Okay, so ini, cara nak kira lah. Okay. So this one, energy, power dia berapa? 2 kilowatt. 10 minutes. Why divide by 60?
Hour.
To convert into hour. Yes, very good. So to convert into hour. And then you use 3 times in a day. Guna dia 3 kali satu hari. April, 30 days. Okay. And this is the charge you have to pay for each unit. Darab dengan 25 sen means 0.25 ringgit. This one must be in ringgit. Okay, Nicholas. So answer is ringgit Malaysia 750. Yang you dapat itu 750 sen. You convert to ringgit. So RM 700 so 7 ringgit 50 sen. Kalau you tulis 750, you kena tulis sen. Okay, baru dia betul. Alright?
Okay.
Senang saja kan? Okay lah. Okay, so ini contoh lah. Okay, another example. You can write, you can determine the cost for each. Okay, we are 3 bulb here, 3 lamp. Incandescent lamp, fluorescent lamp, LED lamp with the power rating for each. Okay, you tengok dia punya power rating. So kita nak beli lampu yang mana satu kita nak prefer. Which one is better? Contoh lah. Okay.
Teacher.
Yes.
Chemistry.
Chemistry is on the way. Okay, sorry. So 3 arcade, you boleh tengok di sini. Nanti boleh keluar lah. So from this, we choose the least cost. Kita pilih yang paling murah lah. Okay, LED power lamp with 10 watt. So you tengok, tak semestinya dia punya power itu rendah. So dia itu tak bagus. Sometimes itu dia punya power rendah, dia lagi efficient. Okay, efficient in generate. Kadang-kadang dia punya brightness sama, same brightness, but the cost is lower. So this is what I mentioned just now by efficiency. They will produce same brightness, but you are advantageous in terms of their cost. Okay, so ini nanti you boleh tengok semula lah. Ini nantilah next time. Tomorrow kita sambung for this one. Okay, so I guess that's all the time we have for today. Five Akid, thank you very much. For Baiduri, 5 Citrin students, 23 of you now. I really appreciate your time and effort. So see you again tomorrow. We continue with more exercises on 3.4 and you can ask any other question related to chapter 3 as well. Okay, so that's all for today. Thank you very much again.
Okay, thank you, teacher. Bye-bye.
See you back tomorrow morning. Bye-bye semua.